Today I'd like to talk about the CNC4A coolant tray. As I mentioned when I was talking about the stand, I decided that I wanted to use coolant. So to stop a mess, you need a tray. You'll see some there, they use wood and they cover it in plastic, or they put bitumen on it, or rubber, all that type of thing, but steel is the best, and it is fairly strong and versatile. Now when I designed the stand, the mill sits above these two supports. If you use thin material and the mill happens to move, it will then drop. I could have welded in more supports, but that does not allow this area underneath. I've got cabling, speakers, all that type of thing underneath there. When I run the benches, they drawers, the tops will come up to here, so that's the only clearance I have to run extra cabling. So that's why there's not additional supports. I went for 1.5 millimeter. In retrospect, 1 mil would possibly be good enough, but I went for 1.5 mil. And the industrial age has passed us by. In the old days, there used to be sheet metal workshops on every street corner. 1-man, 2-man, 3-man teams, and they would be bending up different things. And you could go get something bent up fairly cheaply, fairly easily, and for a good price. But these days, they're all CNC machine, and they all want 1,000, 100, and even finding the material. Some people were charging more than what it would cost somebody to fold it up just for the material. And it wasn't even a full sheet. They were charging more than a full sheet price. So most of them now don't want to know you. So if you find a good sheet metal guy, stick to him. So I found one that would supply the material, but the costing to fold it up was way, way too expensive. Triple the price of the material. So I thought I would fold it up myself. Now, we'll go through these photos and you can see. I first cut it out and worked out the fold size. I wanted a large enough lip so as A, it would contain swarf, it would contain coolant, but also I could then attach the spray booth, the waterproof cover. So that's the idea there. Plus, I'm planning on having a bit of kickboards or lead boards out of the way, but for the door, if you get yourself some V-rollers, it can actually sit on the top and roll. So all you have to do is make up the framework, a couple of rollers there, and the door can slide in and out. So that will be another video another day. So I got the material, I thought no worries. I've got a 1 ton arbor press, and this is the tooling I had for the hydraulic press for bending sheet metal, the thicker material that the press doesn't hold. And the trouble with the hydraulic press is they're actually in a cage. So you can put a long thin piece of material in, fine, but anything that's wider than the width of the gap you can't do. So if you want to put a lip on a bit of material halfway, you're in trouble. So that's why I got the arbor press. It's a C-section and it's open, so you can put your material in and move along no problem. So 1 ton arbor press, 1.5 mil piece of sheet steel, you can get it and bend it like that. You think it's easy. But unfortunately, the wider you're trying to fold, that 1 ton is not spread over 1 inch, it's then spread over 1 foot or 2 foot or however wide your folding blade is. So you soon come to realise that it's going to be a difficult job to fold. So you use mechanics to help you a bit. So what I've done there was I set up the arbor press, got the 50mm lip and started to fold. And on the edge it's easier and it'll start to fold up. So then what I did is I set up framework, it sat in the cradle, and then I grabbed the other side and actually pushed the foot down on the arbor handle, and then lifting that up I used the mechanical advantage of the actual folding mechanism. So instead of 1 ton there, I was exerting more force there. So you move it along and you do your lip slowly, slowly, slowly. So 50% say overlap, then you soon get your line, and it then starts to fold up and fold up and fold up. I then done lap ends for the end. So you have to work out that when you cut your slots, if you cut your material like this and you fold it up, then you bend that one, it either goes on the outside or the inside, but the trouble is it has to be the thickness of the material in further. Otherwise, if you don't go deep enough, if you go 50mm and 50mm, they'll hit. So you have to actually go 51.5 or 52mm for ½ a mil gap. So you then cut it. You have to work out which ones do I fold up first. So I folded both ends, the cut end and this long end first. Then I bent that one a bit further. Then I put this other section in and folded it like that. Slowly, slowly it went around doing it. Then because it's a bit wavy, I then put in long steel sections and just a bit of sheet metal to tap it along. Then with the other end, where I come in, I use my spot welder. You will see the timing mechanism I set up for the spot welder in another video called microsecond spot welding, and I dialed in the first one, and then it was just a matter of spot welding each one, kept the smaller one, the longest one down for more leverage, spot weld it, in it goes. Then just tapping it. So they are now watertight and extremely strong. So for about $150 is what it costs. It's now fitting there neatly. So the next step is that when the coolant runs, it will need a recess, and that's the video I'll be doing next. I'll show you how I'll do the recess and the drain holes to go into the coolant tank. So we're getting there. We either run out of time or we run out of money. So thanks for watching.